Yeah, I thought, because we were desperate, I thought I would just show you some of the stuff I've done over the last, over my whole programming career. Some of it will be interesting, some of it will be dead boring. Anybody falls on the chair, I'll move quickly on to the next bit. So how did I get involved in computers? I actually remember programming a computer back in when I was 14. My dad was into electronics and computers, and he had this massive computer on his desk in his study stroke bedroom. It's about this big, and it was an industrial computer. So it was an open frame with all sorts of cards in, and the number of chips on this thing, it would make a computer today look absolutely fantastic. But in memory, there were all about 2K RAM chips. So this huge memory card of about 32 chips only had 64K of RAM. And you had to press actual buttons on the inside to reset it and so on like that. But it had BASIC on it as a basic compiler. So I just did simple print this statement and do it. And then I remember at school, just as I was leaving, so 16, it would have been about February '83, they obviously got a BBC Micro, and they'd got one for the whole school. And I remember they didn't actually teach computing, so what they did is they set up a lunchtime computer club, and a few of us would go, mainly because we didn't like to be bullied in the school playground, to go and so-called program this thing. But of course, with even with half a dozen children over a half-hour break, you didn't actually get on the computer very much. You had to sit at a desk with your pad, and I remember I only ever did one program before sort of the O-level exams kicked in, and we lost sort of time to do it, and it was a simple for next loop to print 40 asterisks on a line, and that was it. That was my first BBC Micro program. And then we graduated to going down to Finefair on the BBC Micro doing line 10 print, I am great, line 20 go to 10. So that's what everybody did. So that was how I got into programming and computers. And of course, as a kid, once you see these things, you're hooked. And I ended up with an Acorn Electron. And I started to, I think I said at the CAD meet, I started to play around. I was never a massive computer game person. Games sort of bored me quite quickly. So it was always a case of, right, how can I make this thing do what I want? And with the Electron and subsequently with the Master Compact I had, you were always up against memory constraints. I don't know if anybody remembers these old computers, but out of the 32K memory you'd got, if you wanted to do any decent graphics, Mode 0 took 20K. So you were down to 12K. Your program didn't start till E00, which was about another 12K gone. So you ended up with about 9K in high-res mode for everything. So every variable had to be one letter. And I'll show you typical of some of the stuff. I haven't got, unfortunately, I got rid of all my computing stuff back in about 2000 when I gave RISC-CAD to APDL and the rest got trashed. So I haven't got any of the really, really old programs, but you can sort of still see in some of these some very early bad habits. Not so much, now there'd be bad habits. Back then there were essential habits to fit anything into the memory. I'm just trying to think what's the oldest program I've probably got here. Stock. Yes. We'll have a look at this in a bit, but this is typical of the programming that you would get. So, and I actually had to do some work. It was interesting because I had to go back to these programs to even get them to run today. And it just goes to show when you start programming, you've no real consideration at the time that it's ever going to run on anything different to what you've got on your desk. So there were hard-coded in here ADFS, this not, because I'd only got a floppy disk, and with it being the Electron, it was ADFS, not DFS. But you can see the problem straight away here. What's 8%? Another one there, 8%. You can see some of them, because this is actually, like I said, I've not got the very old Acorn Electron program, so this actually run on a RISC PC, where you've got a few hundred kilobytes to play with. But even so, it's pretty poor. And you go further down, I don't know if this one's got any, see I've remmed out mount because hostfs on RISC-PC doesn't like it, and so on. So it's pretty poor stuff. There's copious use of gotos, there's on variable, you run all these procedures and so on. And clearly it's not a multitasking program. There's VDU codes, which are going to turn the printer on and off. There's error numbers, there's all sorts of really bad stuff. And what you can't see is any documentation. That's why even for me today, to go back and try and find out why this thing didn't work is a bit of a problem. Again there, you're equating an integer, a whole number, with a real variable, which is just something you wouldn't think about doing today. So, again, what I tended to do as well, you can see we've gone from 8% to C% here now. So we've upgraded them. Early on, the number of bugs I had, where it was simply a case of 8% cropped up so much because you're thinking, right, I want a letter for a variable, you start at A. So 8% was always the one that got it in the neck. But what would happen is your program would do some really odd things simply because virtually every program you thought, every variable you wanted ended up as being 8%. So you got about 38%, which ultimately would start to interfere with each other. So that's an example of how bad things would start up at. I mean, what's TT string? What's DE string? It's awful stuff. And all the text is English as well, so anybody who wants to translate this to a different language has no chance. What does it do? We'll try and run it. I don't know whether the projector is going to cope with this, or it's not done too bad a job. So this runs in obviously non-window environment and mode 12, so it's 40 by 80, I'm guessing, or 80 by 40. And it was a stock control program. I used to work for a company that made circuit boards. Well, one of the things it needed was circuit boards as part of the larger equipment it made. And some of these circuit boards were a foot long and 8 inches high, would have several hundred components on them. To go through the Farnell's catalogue and start writing numbers down on all this, every time you wanted to place an order was a nightmare. So I wrote this, and what we could have is all the stock items in the top here, and the bottom was a parts list for a particular program. I'm going to press menu, and this will amaze you. Look, it had menus. Well, I think it's locked up. I didn't do this on me today. That Sprite doesn't exist. That's something I always tended to build in. I know what I've done. I haven't given it any Sprite memory. I'll just go and put some Sprite memory. A lot of these early programs, like I say, because the WIMP didn't exist, you had to, it captured areas of the screen for sprites. There we go. So we have menus and pop-up menus, and actually anybody who knows when the Master Compact came out, the Master, they supplied almost like a WIMP front end for it. It was a little desktop. It was all written in BASIC, and it had a calculator, notepad, filing system. I pinched the menu routines from it. We had a menu. Like I say, I don't know whether this is going to work or not, but we should be able to. And you see, it goes down the thing. Let's see if it'll go far enough to get to the. There we are. So we've got all the things. Now, this is a good example of, again, you don't forward think when you're doing programming. If I press the down key, whoa! Modern computers are just so much faster than the old Acorn Electron. The Acorn Electron ran at an eighth of a MIC, 125 kilo instructions per second it was. Half the speed of the BBC, which was a quarter of a MIC. So you threw it in no time. So it's unusable today unless I put something in to slow everything up. But that's what it could do. And ultimately, then you would go and you would say, I want to generate an order. So you'd put in how many of the particular parts list you would do, and it would spit out the orders for RS, Farnell's, everybody else. And then our poor secretary would spend 2 hours on the phone to Farnell's saying every part number and the quantity. I think she absolutely hated me. But that was it. And you could change the palette. And again, all these were, handwritten, so you could change the colours and everything else. So it was quite an interesting thing, and it did actually get a heck of a lot of use, did that, before we stopped using Acorn stuff. So that programme probably goes back to about 1986. Probably one of the first programmes I wrote on the Archimedes, and that was probably under Arthur. So there was no WIMP environment. So we move on then, and I went to college after school. And in college, I was doing just a general engineering degree, which involved mechanical engineering, electrical engineering, and electronic engineering. And I was thinking about this today. I thought, I don't ever remember being taught programming. And I don't think we ever were. We did programming, we did microprocessors, and we had a circuit board about the size of that laptop, which was again all open plan. A little keypad, not a keyboard, a keypad, no monitor. All you had was about seven segment digits. And you literally called up the address on the first four, and the next three were either what was at that address, so it would be an instruction or a value. And you had the book of 6502 assembly codes, and that's how you programmed it. And to this day, I know that A9 is load accumulator, 85 is store accumulator, and so on like that, because it was just, that's what you ended up doing. That was the only way of programming it. But I don't ever recall the lecturer saying, right, this is what you need to do. It was like, there's the gear, there's the book, I'm stood at the front doing the crossword. If you get stuck, give us a shout. And of course, nobody really ever did. In fact, what I found was they kept coming to me saying, how have you done that? And I just obviously had probably a bit of a natural affinity to doing this sort of thing. One of the questions I'm asked quite a lot is, how do you program? And it's an interesting question, because it's like, I can tell you how to program, but that's no good. I could tell you how to beat Usain Bolt in the 100 metres. You simply put one foot in front of the other faster than he does. But it's it's got to be. I like puzzles and I like jigsaws and that sort of thing. I think you've just got to have that mindset. I think if you have to ask how to program, you're never going to do it. And also, I do talks at various colleges and schools, and again, another common question is, how, do you know Python? Do you know this? Do you know that? No. That's not programming, that's learning a programming language. And we'll go and look at C. I taught myself C some years ago, and I think anybody who's got a mind for programming could probably learn a new language fairly quickly. Just give me the book, and I'll suss out what I need to do. So we looked at Stock, one of the first ones, and obviously I started then with the CAD software that you saw a few weeks ago, RISCAD. But RISCAD is an evolution of 25 years of writing and rewriting the same program, adding bits to it. And at the time, at the early 90s this would have been, there was a lot of interest in microcomputer CAD, as I said. So I would get magazines of PC programs and look at the screenshots, because that's really all you got. I thought, right, I want that on my screen now. So this is what I'm going to do. So that's where a lot of the icons and the screen furniture came from, and the cursors and so on in RISCAD. But again, I was thinking just the last few days when I was putting sort of this together. Actually, when you looked at it, none of it was very complicated. I remember being sold a right. Feeling a bit conned when I bought my Master Compact, because I remember looking at it. I had an Icon Electron, which always struggled for speed and memory, and I saw this Master Compact in the local computer shop window, and they'd got I think it was a Mandelbrot picture on it, with all the cycling colours. And I thought, wow, look at the speed it can update the screen. No, because all they were doing, they were colour switching, that's all they were doing. A few simple VDU commands. So I went in and bought this thing, got it home, and found it wasn't really, it was only twice as fast as the Electron, and no real improvement in the BASIC or anything like that. They all had the same version of BASIC and everything else. And I think I came to the conclusion today that was similar to these PC CAD programs. It was all down to the marketing. It's in your magazine, put a nice picture in, showing a nice fancy thing, But it's like, when you get the programme, it's like, well, I could have done something better than this in a few days. And I was reminded of Mr. Churchill and the Battle of Britain, of course, which we just sort of remembered, and I thought you could swing this to, never has so much been paid by so many for so few, in brackets, lines of code. Because it was, I went home and did all this, and it was like, oh, blimey, is it that easy? So let's have a look at one of these. Now, I know this probably won't run unless I go into command line, so you have to excuse me because I tried all this earlier and it does work, but I've just got to. I keep forgetting to put a star in front of everything because you're just not used to doing that these days. Like I say, you need to bear in mind with some of these that some of these programs are getting over 30 years old. So it's yeah. I look young, but I'm not really. Right. If that was a full stop. Look at that. So this was, I call it ARMCAD because RISC-OS hadn't been invented up to this point. This was started in about 87. So it was an ARM processor, so it was called ARMCAD. And it wasn't even intended for a mouse. That's why that looks quite rough and jerky. I can make it even more so, because if you look at the snap at the top, what it's actually doing is moving by a certain grid size, which I can increase or reduce, because we had a Marconi tracker ball, and you could whiz the tracker ball going and see the cursor go across the screen. That's why it was done like that. But like I say, this is very similar to how a lot of the old PC CAD programs would have been. A non-official windowing environment like Windows or RISC-OS. It's you wrote your own window, you wrote your own icons, you managed it all yourself. So again, we've got various drop-down menus, and we've got toolboxes that we can go and draw. There's very little technical ability to this program. It's very much it does what it does, mainly to the grid, not much else. But it was something we made heavy use of. Like I say, the engineering company I started to work at made power supplies. Large power supplies. The biggest one we did was 60 volt, 100,000 amps. And I'll show you a picture of the transformer and the rectifier cubicle later on when we get RISC-CAD going. So everything was a one-off. You never made two the same. So a lot of it was done on this, and I would be beavering up and between the screen and down at the transformer that weighs several tons with a tape measure, making sure that what we'd been told was coming came the right size. It did do automatic dimensioning, so I could go and put dimensions on and everything else. So it was quite, in a way, it was okay. We had a guy in doing some temp work for us who used to run an early version of AutoCAD, and he was saying it's very similar. There's no big difference. We could do curves, something RISC-CAD users waited 15 years for. I got them going on this. And quite interestingly, automatic. Oh dear, again, it was all keyboard stuff for panning and zooming. If you press the space bar, it's centered around where you were, and something like that. And we had a plotter, so again, you could choose which layers to plot, customise windows for which pen, and so on like that. So again, it was quite advanced for its time, but it was very much like a lot of these programs are. They're in their own world, they're in their own environment, and you would get people sat at desks with them. It was myself with this, or people with the PC programs, and they were an expert in that program. You put them in front of another program and they wouldn't know what the hell to do, because all the key presses would be different, all the screen furniture would be different. There was no standardisation. So that was ARMCAD, which did evolve into. You see again, the mouse is so fast. Come on, you know you want to. Oh. So that was ARMCAD. Again, I said with the talk on RISC-CAD, with this early one, it started out on the Master Compact as MicroCAD, Now the Master Compact had 64K of memory, 32K main memory, it had shadow screen, and it had sideways RAM. And I ended up with some procedures out of Acorn User that let you take chunks of your program that weren't being used and move them to sideways RAM, and move ones out of sideways RAM and put them on the end of your program. So I could put big chunks of program, I could shove them away to squeeze as much in as I possibly could. And it used all 4 banks of sideways RAM and pretty much filled the entire machine, and it became ARMCAD. And again, if we just go down, there's no prizes for guessing what this is like. It's absolutely awful, and I would hate to have to go now and just try and do anything with that. And there is some machine code, I think, down here as well, because again, all the machine code was compiled as the program run. There we are. I mean, that's even worse than the basic. If anybody can tell me what that's doing, it's...
No comments on it.
There's no comments on it, no.
You were dead proud of it at the time, wasn't it?
Sorry?
You were dead proud of it at the time.
I probably was, and I probably knew what every line did, but going back now, it's just... But again, it's funny because sometimes you do, like, you know, who knew when I wrote this in 25 years I'd be here trying to get the thing to work to bore you lot with. So that was ARMCAD. I'm going to leave that over there. And those 2 programs, the stock control and the ARMCAD, sort of formed really most of what I did for quite a few years, except one little incident where, again, like I said, my dad was into electronics and computing. Not so much the computing, it was more the industrial computing, like I said. And he'd done an old computer hardware for Boots the chemist in Nottingham, and they wanted an upgrade to it. So it came to me, it would have been in about 92. He came to me and said, how do you fancy doing this program? Yeah, fine, okay, I'll have a go at that. And he said, oh, by the way, we need a user port, similar to what the BBC, we need to control some hardware that he was going to make. And it's like, oh, heck, great. So we looked around and we decided to do it on A3000s. So they bought 2 A3000s, which at the time were £640 each, so it was quite an investment. And I set to writing software. For one of them we bought a computer concept RAM disk because we wanted permanent backup in case the power went. And we also bought, I can't remember whose company it was, I think it might have been Oak Solutions, because I remember going to Bradford for it, an 8-bit user port. The problem was we wanted 9 bits, which he broke to me halfway through writing the program. We need an extra. It was tough. We ain't got one. Anyway, we phoned the company up, and it turned out there were 2 8-bit ports. One was used as the print interface, and one was what they give to you. So we were able to cut the tracks and bodge up this 9-bit user port. And we ended up. What it was is Boots had a. Obviously, you can imagine a modern warehouse where they've got trucks pulling up to these big loading bay doors, and they've got inside there, they've got forklifts running around like flies with pallets on to go into trucks, and they want to know which door to go to. So above the door, they wanted just a big 5-digit sign with a code on, and the code would be the job sheet that the truck driver has, so he knew which one to go to. But they'd got an office at one end of the warehouse and an office at the other end, and they wanted 2 computers that would basically mirror each other. So whatever you typed on one also happened on the other, and either one could control these loading bay doors, the signs for it and so on. And there were also some micro switches on the doors that told they wanted to see when a truck was there, so it could be opened and so on. So Dad did the hardware, and I set to writing the software. And I forget this because he told me how to do it, because he was always a little bit of a know-it-all. And he'd written the original software, so he said, right, you do it like this. So, and he begged me off to the caravan for the weekend and left me to do it. And with any program like that, one of them has to assume control. You can't have them both fighting each other because there's communications between. So I said, right, I'll write one program as a master, one program as a slave. And I did these, and they would run perfectly for a while, and then every so often it would say communications lost. And they're only 2 feet apart in the bedroom. And I sat down, and this was probably midday Sunday, And I thought, the pillock, what he said, sorry if you're going to have to bleep a lot of this. And he said, what he told me could never work. It was sort of one of those moments where you started to think for yourself as a programmer and thought, that's rubbish, that will never work. Rather than just accepting what you're being told, it was like, I'll think this through and I'll sort it out. So, we ended up with still a master and a slave, but they were called that simply because the master had the rounded skin and the slave didn't. That's the only difference between those two programs. And what they would do, the way it would work, right, if I run it, it'll beep a lot because it can't talk to its compatriot. So it says at the bottom, communications reset, and it's not listening. But basically, it wasn't intended to multitask. So the mouse is enabled because I've enabled it, but it wasn't there originally. It's all tab key and arrow keys to move up and down. And they would put the trailer number in here, and then they could put just some notes in here. And then they could toggle those last two would be coloured lights that would come up on the thing, and I think F1 is the destination status and so on. And the status symbol would change depending on whether there was a trailer, so that was something it was reading in. And the idea was the other machine would have exactly the same display as that. And the way it worked is if somebody was in that field, it wouldn't allow the same field on the other machine to be changed. So one would override the other if it had to. But it was interesting because got down to boots to install all this, and not every trailer had 5 digits which were allowed in there. Some would have fewer digits. And what I found was, which is not apparent, when you don't have a full icon, say you reserve 5 digits in the WIMP for that text, if not all 5 are used, garbage appears in the other ones. I thought naively it'd be a blank space because you don't see anything on the screen. So on the display you get 667 space where the carriage return was, and then it could be anything. It's like, oh my god, what's happening? So I had to quickly patch some machine code up to basically blank out the letter characters with spaces. But we were packing up to go home, and I'd left something in the offices. And I went back to one office, and it didn't take the users very long to work out that what they put in here was seen on the other one. So they were ordering the lunch from the other person. They put bacon sandwich, and oh, how are you? I'm fine, thanks. So all that effort I've put in, and that's all they're using it for. So that was quite interesting. So we'll get rid of that. So that was Boots, which was my first paid job. Actually, that was probably the first and only time I've been paid for programming as an actual program, other than obviously selling this car. But so that was quite. Is that one down already? Right. So that was Boots. So this sort of takes me into then commercial software. And I remember I left that company, went to work for a company over in Swinton that did emergency lighting fittings and large central battery units, as they're called, to power the fittings. And again, Dad followed me. And they wanted us to do... So I went into the engineering department, he went into R&D. So our paths didn't really cross after that. And they were trying to use AutoCAD. And they've got a pirated version of AutoCAD 9, which was, again, a DOS-based program. So, again, it wrote all its own windows and everything else. And it's not particularly good for simple drawings, isn't AutoCAD. And they were trying to teach a 55-year-old engineer who I started working with. They said, you're never teaching CAD, you'll never do it. We've tried, you'll never do it. And he used to get the drawing board out. And what he would do, they would draw on, basically, acetate tracing paper. And every time he wanted a new drawing, he would find the nearest one in the drawing packet to the one he wanted, photocopy that became the old original, and he'd start scratching out and tipexing the bits he didn't want on this to update it. So these drawings, they looked, it was a forger's, there'd be all sorts of bits and so on. So I took my I took my RISC PC that I had then and showed them RISC-CAD. And one of the things they were trying to do, I need to run the latest version because of the old. We'll look at the old ones, but all the drawings have been updated. So one of the things they were trying to do was battery layouts, because when they sent somebody a unit, the batteries came separate, and the installers needed to know where the batteries went. So let's have a look for it. So this is a typical battery layout. This is a battery on a rack. So obviously just a plan view showing the connections of plus minus, just in case you don't know, and so on like that. So that would be sent. And they've got a whole load of catalogue product that they were trying to get somebody, and this somebody just happened to be the MD's son, to do these battery layouts. And he'd done one in about 5 days, and it was awful. So I took this in, I did about 8 in a day. And it was like, he was on the shop floor the next day, and I was sort of in engineering. And eventually they bought about 6 or 7 variation of RISC PCs, A4000s and A5000s, and they had a full CAD suite, and they had, you'll see later, they asked me to write them some quotation software so they could sack all the typists. so that was what I was sort of doing at Menvia for quite some time, and I did that for 7 years, and we had templates for everything. So all the engineer had to do is when he pulled up if he got anything complex, he would give it me to do. So he wasn't fully indoctrinated, but then the guy was going on to retirement. And this is typically what would happen. We would have a schematic like this, and if he needed to add a bit to it, he would just pick it and plonk it on, and he knew how to draw straight lines and so on like that. And that's what he did. It was funny because if ever I went in and had a look, you would find about 8 lines on top of each other, or he would draw a line and it would finish short. So he'd put then another one in like that, and you'd find all these lines made up of little lines. I'd go in and try to tidy it all up for you eventually. But or you'd find things where he'd pasted it, because some of the symbols I made them paste just at a common point in the corner, so he didn't have to think where's it go. They all worked relevant. But some of them he'd put it in the wrong place, so it'd be off the top of the paper. And you'd always know when you were plotting the drawing, if the pen got to the edge and stopped for about 10 minutes, there was a load of stuff that he'd pasted off the edge of the drawing, and he was trying to plot it. So that's what we ended up doing. I said I'd show you the transformer for. So this was the Union Carbide job. So this was a good example of. This is why I had to sort of write DXF import into it, because RF Winder, the company in Stanley that makes large transformers, sent the DXF file. And our job, these were the buzz bars coming out of each side of the transformer. This was all oil cooled with all the various cooling equipment on the front, big transformer tank at the back. And we would come out and we would bolt buzz bar, i.e. large copper bits of bent copper onto these with thyristors that size to handle thousands of amps. And so we would need to accurately know where all those holes were, because you can see the height of this, 2 meters. That's one of 4 of those, and they would probably all 4 would probably just about fit in this room. So it was pretty big stuff. And the buzz bars going were 1 foot high, 1 inch thick, and there were 14 going out and into another room where the furnaces were. So it was quite important that it was relatively accurate. But like I say, that's a drawing that's been converted. That would have been done, I would guess, on the original non-multitasking one that we looked at before. So I said so we moved on to sort of the industrial work. The bread and butter CAD work that I was doing is just part of the engineering, and always the CAD was secondary. And it was great going to Menvia because, as I said, they bought several computers. So all of a sudden you've got the opportunity to play around with networking, and that's where a lot of these applications come from. A lot of these wouldn't be there if it was just a standalone program. But all of a sudden we've got 2 plotters and 6 computers. Well, how's that going to work? Well, we need a plotter driver. So that's where NetPlot came from, and the subsequent plotter queues. We wanted one library. So again, it's an application that would sit on the server and just be accessed by different things. And that then led to, well, what if somebody updates a symbol? Or rather, what if somebody deletes a symbol and your browser is looking at it? Oh dear, that's not very good. So one of the things I did, as I wrote a small module that trapped an upcall that looked at files changed on the disk, and if it did, it redid its library browser. So all of this sort of came about really from the fact that we were suddenly hooked up to a network. So that was, like I said, the CAD was something I did, and none of this would be done at work. It would all be done at home for several hours. I remember occasionally doing literally all night, because once you've got something in your head, an idea, you certainly didn't want to sleep, you didn't want to let it go until you'd got it all down in the program, as much as you could anyway. So that sort of developed just to make my life easier and to make the people who were using the system easier. But engineering was always what I was paid to do and what I was doing. And then I said my dad's Pat and I didn't really cross again, but they did, because what they wanted was, when you've got light fittings in a building such as this, some of them will be emergencies and they'll be powered either by small internal batteries or by, as we saw, a big battery somewhere else, and that becomes more economical if you've got a lot of fittings. And also that battery might last 25 years, whereas batteries in fittings last 3 years if you're lucky. The problem you've got with batteries in fittings is you've got to go and test them. You can imagine this ceiling's not too bad, but if your ceiling's 4 metres tall, you've got to suddenly get platforms up, and it was labour intensive, so the fittings were cheap, but what we were trying to sell to the end user was the maintenance is going to be horrendous, cost-wise. So we wanted something that would talk to the fittings and get them to automatically test themselves. So we developed a small piece of hardware that would go inside a fitting, it would measure the current, and it would be able to talk back to a central computer. But it needed some support. So one of the first things we had to do was prove the concept of it. The system was called CentralTest. Now again, I'm not sure this will work, but it won't do very much because it's expecting to talk. And this was a dummy system we set up. We had 4 fittings. It showed how you could put the location in. So again, it wasn't just fitting 1, fitting 2, fitting 3. It gave some description to the poor maintenance guys to where it was. And it would have, what it's trying to do here is go around all the fittings continuously to talk to them. So in other words, is the wire okay? If they need to come on, can they come on? This wasn't a separate communications cable. This was data being sent over either the mains to the fitting or the DC power to the fitting. So it was almost like your broadband is now. It was all superimposed on the power wires. So that's what it was doing, and you could schedule a test, and it would do a test and say, you would tell it what the reference current needed to be for, say, an 8-watt tube or a 16-watt tube, whatever tube was fitted per fitting. And it would come back and say it's within tolerance or it's faulty or whatever. So that was like a proof of concept. I think I have to quit this from here because there's no quit option on that. Again, it was demo software, and we didn't want anybody playing with it and knocking it off. So that was that, and I didn't get involved after that with the programming of it, because it was an industrial panel. That's all it was with the micro in it. But what I did get involved with is somebody, one of these large sites, you could easily have 1,000 fittings. Somebody had to type in all that. It's in the reception hall. It's in the, and that fell to some of our admin staff. But they needed a program to do it. So I wrote this one to start with, and this has gone through several versions, not because it was ever improved or anything, it's just that the requirements of the panel changed. So here we can go up and down, up 1,000 fittings I think, 1,024, as you'd expect for a computer. And you can put in the address of the fitting, so if a fitting went faulty and it was address 5, they didn't need to replace it with address 5. They could replace it with, if address 7 wasn't used, and they could tell it that fitting is now address 7. Which zone it was in, what clock and so on. And then you could program, flush the output buffer, view the serial output as it was sending it to the panel. Because all of this had to ultimately go in the wall panel. So it was all done there and all that, because that's board rate and so on. So again, that's just something that, and obviously then you've got cut, copy, paste and everything else for the person who's entering all that. And then we had export, and you could export text file, an address sorted list, a commissioning sheet for the commission engineer to go and get it first. and that was something for the panel that it needed to go on in the control panel. One interesting thing with when you write stuff like this is you never expect it to be put to the use it gets put to. So I remember the address sorted list. It's literally a text list. It won't show anything because it only output fittings that had actual data in. But it was just a list, and if you've got a lot of fittings, it could be several hundred, literally that, but as a text file, so address, zone, clock, data, and they would repeat and repeat and repeat. And as a joke, I put at the end, remember all the Looney Tunes cartoons where it goes, that's all, folks. I put that at the end of the text file when it got to fitting number 1024, and I was called into the boss's office. He says, "What's this?" And somebody unknowingly had printed this out, sent it to the contractor to check it, and I never expected this to leave the building. And I got a right roasted because it says, "Get rid of it." So you just never know.
No.
So that was set data, and like I said, it went through several iterations. This was one way you could set timer channels, so fundamentally the same program, just slightly different. And the export list got ever more. We've got PC format now, because I think we were writing it for a PC as well. It would tell you if there were duplicate addresses, so if there were more than one, if the contractor had miswritten the address down, or the shop floor has sent some fittings out with all with the same address, it would do a list of that sort of thing. And then the last one, which I did just before I left, I was trying to emulate sort of the current trend in PC Windows, where you could have different tabs, and these would move to the front or back, because there were 4 zones you could have. And also, you often got the situation whereby sometimes the data sheet wasn't complete, or it wasn't easy to read what the contractor had written. So I made it so you could tag this with a sticky note, and so if you've got records that you needed to come back to, you could just go and see, oh, well, that zone, there's an issue on it, and so on like that. That was something I did. So again, just slight iterations of such. I think if we look at this, we'll probably see slight improvements in that the variables have more meaningful names now, and also there's a little bit of coding. The other reason variable names were short and there were lack of comments is, don't forget, BASIC, even now, for most programmers here, is an interpreted language. And every time you have a larger variable name, it's slower to decode. Every time you put a comment as a REM statement, that has to be identified as a REM statement and jumped past by the interpreter. So all these things do add delays to program. So it's another reason why, if you could use the variables capital A to Z, they're hardwired into BASIC to be accessed faster. And also, if you couldn't, once you'd used those 26, if you could use smaller variables, they were quicker to decode. So that was another reason programs weren't littered with comments, as you can see. But spaces have started to appear. There's indentation for the loops. There's reasonable clarity, although still not. There's some comments. But you don't expect to comment every line. You would expect that somebody there will be able to see roughly what it's doing. So there we go. So that was part of the industrial stuff that I did for Membia. And then, like I said, they asked me to automate the office. Now, I'm not sure how much of this will work, because again, it was all networked up. But that came into a couple of programs. These are what's called, we'll call it at the time, expert systems. And again, because they're written for a particular company, for a particular application, to do a particular job, you can't take them out of that and really use them somewhere else without a lot of modification. But what they were tools to allow them to do quotations. If you're an engineer, the biggest bane of your life is salespeople. Salespeople either sell what you haven't got, when you haven't got it, and for the wrong price, and it won't fit in the cabinet that was quoted. They're the main sort of fundamental flaws. So it was always loggerheads between engineering and sales as to, we can't fit that in here. Well, you have to, because that's the only room the contractor's got. So we set to come up with a way of stopping them doing that. And what it boiled down to was A, to get the price right, and B, to make sure it fitted the cubicle. So there was an engineering side to this that could choose. I just knew that wasn't the right version. Let's see if we can find the right one. Here we are. Oh, no. This took quite a sinister turn actually, because we had some people who we thought weren't really doing very much in the quotes department. So the software actually spied on them. It would record what files they opened and when, and write that to a log file. So we could, at the end of the month, say, well, this person only opened one quote file last week. He just sat looking at it all week to look busy. And it did actually flush a couple of them out. Anyway, so we've got here, this was a slightly extended version of it. So we've got, we could choose the cubicle, and as you can see, each cubicle has a points value. So it was a simple case of then, what you're going to put in there. Well, we're going to put one of those in, and it would have a points on this one hasn't. Because this is really a different set of data from what we would have. But you can see the idea. You would drop in what you wanted. It's adding up the price. It's adding up the quantity. It would add up the cubicle points, and it would tell you then how many points you've got left. And it did prove to be quite accurate. So in the end, it did the job, and it meant also then we could go to the pricing and put the markup, and it would tell them what the selling price needed to be. So it did do a pretty good job, did that. And then what they could do is, I don't think this will work. I tried this today and I couldn't get it to work, but we'll give it a go. But I think it's going to come up. But I can show you a separate program that gives you the idea. Oh, okay, it does work. So this would then let them do the quotation. So again, they would put in the quote number, to create a new one, open an existing one, what it is, how many it was, and then they could go, and a copy quote was the covering letter. So they could say, there isn't one there, I want to add one. And you could choose one, and on the actual system you could choose one for whatever the customer was, or the sales rep name was. I haven't got impressions, so I can't edit any of these, unfortunately, to show you. Prices page, again, it would add the thing that we showed you, a blank for adding up. The text brief was the text spec, so it would drop one in there, again, depending on what type of equipment you've got. And then correspondence, you could have a covering letter. Again, it won't edit because I don't have impression of all this. But you get the idea. The good thing about this is that, again, non-computer people, and my wife is the worst at this. My wife turns her PC on and the desktop is just full of files. And I say, have you got those backed up? Yeah, where? Oh, I don't know. No, they're not. They're on your desktop, which is effectively on your drive C. And it's the same with non-computer people. Things will get everywhere. So what this did, it didn't ever give them access to a file icon. It hid the files away where they couldn't see them and couldn't get access to them, and therefore couldn't load the wrong one, couldn't overwrite one, couldn't change it if they weren't allowed to, because we had various password permissions on here. So only certain people could do certain things. So it was a very good way, and it again allowed people who've never really touched a computer before to type their own things. They used to have a typing pool with three admin ladies in, and they would, it would be back and forth, or you've misspelled that, or you've misspelled a guy's name or whatever, and all that disappeared overnight, including the three ladies. So that was, again, that was just part of the thing. And what we often had, we had somebody who was sitting there doing all the printing and sending out, because we would get, you would do a quotation for a building. Let's say it's this sports centre for the lighting. And the customer who wanted the job doing, i.e. the sports centre, would then go around every electrical distributor local and say, what's your price for this? Because the manufacturer, maybe, would give distributor's discount. So it was who was willing to give the most discount onto the customer. So they'd all come asking for a copy of the quotation to see what discount they would get. So once the quote went out, you would be inundated. So again, all the guys had to do was fill in this quote number, who it was to go to, and click copy to, and it would send it. It would send it to the girls' computers like just a list. And then when she did them, it would go back and tell them that it had gone out. So it was a sort of an early version of email that was going before. Okay, so that was quotation, and then I did a similar one for those guys in engineering, and you'll see the similarity here. I'll open the file this time. So very similar thing. Technical section, drawing section for test plan, test results, declaration of conformity, and all of that. Letters, fax memos. You can see what's happening. Again, it stops people saving files where nobody else can find them. So whichever engineer logged into that quote number could open all of that stuff up. So again, it was quite useful to be able to do that. I think I mentioned in the CAD thing, then we got onto lottery tickets, and this was rather an embarrassment because we used to have a lovely lady, Mary, used to come round every week selling lottery tickets for some reason or other. And she would spend half the day then folding up the counterfeit and putting it in a bag and coming around for somebody to pick these out. I said, Mary, what are you doing? I'll do you one of those. So I did this, and what she would do is she would come and say to me, right, I've sold up to number 132. So 132 became the highest number it was going to pick. And we had 3 prizes. And that was basically it. I did the numbers in Artworks, and it would just, and what I used to do is I said, look, I know if I ran this program and stopped it at the same time every day, to get exactly the same numbers, because that's how random numbers work on a computer. There's no such thing as a random number really on a computer, because it starts with the same number every day. So I used to say to her, Mary, you press the button. So she would press the button, it would go a few more random numbers, so she couldn't see a number and stop it to get that number. It would carry on a little bit, and then it would pick the numbers. And like I said, the first week, the top 2 numbers were mine. In fact, that happened quite a bit, but they never sort of. I wasn't doing anything underhand.
You could see the random number generator to avoid that problem.
Yeah, but you seed it. You're hard coding the program. You're likely to seed it with the same number.
No, what you did, well, I can't remember the exact expression, but
you can ask for a seed.
You seeded it with the time since the machine was switched on, if you see what I mean.
Yeah.
And that was reasonably random.
But you can't seed the R&D command in BASIC.
Yes, you can.
You couldn't.
Yes, you
couldn't.
Yes, you can.
Number equals
Always
random
could.
minus number.
Ah,
Sees
okay.
the random number.
Yeah,
Fair enough.
funny expression. You signed a sort of.
But you'd have to ask for the seed.
It was something
You
like
can
A
generate
equals
the
round.
seed like, yeah.
I equals round brackets minus
negative
time. Well,
number.
it didn't matter whether it was A, B, C, or A, anything.
Or you could measure how fast they're moving the mouse, taking some human input.
Well, that's what it did. That's what it did. She had to press the. It was going so fast. It was running this loop thousands of times. So, but yes, no, I'll take your point.
They used exactly the same thing to generate, I think, a number for who won. I think the members' lottery or prize for at one of the shows we gave away the first one at the time that we gave away a Raspberry Pi. We then had a prize just for the members, and that's the same problem.
Yeah.
So yeah.
But even on PCs these days, I run certain programs and you can see it's the same every time you run it. It's the same.
Yeah.
So that was that. And it eventually came to the stage where I say, don't give me the tickets. You keep them and then tell me if I've won. And often she'd come in with a 8-pack of beer and a bottle of ice. Oh, if I must drink it. Okay. So I think we've gone through quite a bit of stuff there. One interesting one. It's not all sort of work. Sorry, it's not all sort of plays and this sort of thing. This was one I wrote for a particular reason. You saw the large rectifier we did. Well, that was typical of what we would do, but there were some situations where most people know how a transformer works, whereby you put coils on one side and you put coils on the other with an iron core, and voltage is induced into the other one. The problem we had was we were trying to induce so much power. We often have transformers where the secondary turn was one. It was one turn and that was it, because it was, and this turn, it wasn't cable, it was buzz bar going around this thing.
Gee.
So you had to get your calculation right, because these transformers were sort of £40,000 plus. And so I wrote, my dad asked me to write some software to try and see whether we were on the right track. It started out as I was going to write an oscilloscope program, and that's why it looks like it does, but it never really got further. And so most of this program was about, you could save the graphic, you could alter which traces were on. There were 6 traces, colour of them all, the axis, scaling, display, dots or lines. And then the idea was you had a user menu, which would be almost a bit like programming MATLAB now. It'd be specific to the task you were doing. And this is one where we had all these variables, which is phase angle, inductions, resistance of the coils, and so on. And we'll see what happens as we start adding stuff up here. So I'm feeling, if I put, this is which trace number of the scale. If I put 1 and 200 there, and you'll see it doesn't appear to do anything at the moment, because all it's done is show you that there's no information in these traces at the moment, because once I run the calculation, I want to be able to see what it's doing. And this was sort of quite an eye-opener for me. It was the sort of first time I'd written some software that was going to make, 30, 40, 50,000 pounds worth of life or death, not life or death decisions, but job or no job decisions at the end of it. So that was what it did, and then we would say, redo phase, whoa, look at that. And what it's done from time 0, all the maths calculations that we put into it for inductance value. If you know about thyristor and waving, you can see there's an AC waveform going on here. And each one of these different coloured traces is a particular thyristor turning on at a particular time of the waveform. These weren't single-phase transformers, they were often multi-phase. So as one arm comes up, that thyristor gets turned on to conduct, and as that passes primary position there, it gets turned off, and the next phase, and slightly further along, comes on, and that thyristor gets turned on, and so on like that. So you could see then the waveform building up, and if we run it again, then you see it's stabilised now. Time's moved on, and the waveform is sort of stabilising. And then what we could do, we could go down here and play this as the inductance. So you pay more for a bigger inductor. So let's see what that's done. I smoothed it out as you would expect, but you pay more for it, or you pay less for a smaller inductor. But you're going to need a big cap to smooth that off. So it was a really good example for me, as I would only have been maybe 22, 23 when I wrote that, to say, blimey, that's the real value of some of this sort of software. If it can show you that and save you a fortune in not only money, but if we'd have had these things made and they didn't work, we can't get any others made for another 3 months. So it was a good example, but it didn't, like I say, it didn't really do much else other than you could change the various things. I don't now know what half of this does, I have to admit. It just, but at the time it seemed very, very worth it. I won't show all these products, I might as well just quickly cycle through them now. I did write a shell program. Back on that. It was a bit like some of the modern WIMP libraries now, where it was a shell program for you to go in and add your own, so that you've got various menu things, and you've got sort of some default templates and the procedures that went along with it. So this is probably better documented and better laid out than probably anything else I've ever written, because it was meant to be then heavily manipulated. You'd add your own procedures for those things. So I suppose in a way it's a bit like what Dr. Wimp has done and taken on. Very, very short program, but it was just the basis to say you didn't have to look up every time. How do I get a window on the screen? How do I initialize the window? And so on like that. It was just that you could go in and start changing these things and get a program reasonably reasonably quickly. I just noticed actually like this is a library, amazing what you find out years later. Never knew I'd done that.
It's one of the things that you do as a programmer. You make libraries. You make libraries of things up.
No, I'm going to come on to that. I've never have done. I've never bothered with libraries, and I've never used any third-party libraries simply because you tend to, like I said at the CAD one, write something once. That's it, and that tends to be what I've done. My routine to set or grey out an icon or shade a menu entry is just as good as anybody else's. So once you've written it, you don't really need to use anybody else's. And also, as soon as you start pulling libraries in, you've got to remember what was in that library. And ideally, when you write libraries, they need to be a little bit independent. But unless you're good at it and you put a lot of thought into doing it, programmers always want to. It's like the ready, fire, aim business. You want to code first, design it later, and document it last of all, with the absolute intention that the documentation side will never happen. So I never bothered with bolt-on libraries. I like to see the whole program. That's interesting actually, because one of the things I did have on the list that I totally ignored to cover was how you actually program the early computer. I remember getting the Acorn Electron, and I couldn't afford programs for it, so I would often try to write my version of other programs, and one of the ones was WordWise.
Right.
So I wrote a very simple program, and I only had the tape, and it just let me type, and it would just literally spool what I typed to disk, and you could reload it and add to it. So it was a bit of a simple word processor. But to edit a program with no editor, you had to basically, you were using, that's why you've got copy keys on your keyboard. You would press copy, use the arrow keys to go up, copy, change the bit you wanted, copy the rest line, press return. You never really got to see the whole program. As an example, what you would have to do, let's just have a look, see if we can just drag up a basic program from somewhere. So imagine I haven't got an editor. Yes, please. Now, whoa, where did that go? So, all right, you press Control-N, which I think pages a bit at a time. Let's now try and get it. And it's still going about 50 screens at once when I press Shift, because it's just all too fast. So you got to a stage where you couldn't edit anything big. So, fortunately, I didn't invest in tool chains. I still think that the price of tool chains on Acorn is ridiculous. Today, I've bought from Amazon a 500 gig USB drive for this because it's only got an SSD that's quite small. But Microsoft are now giving away their Visual Studio free of charge because this is programming tools that would probably cost £1,000 to professionals, and they still have to pay. But one-off people can now have this for free. Not a cut-down version or anything like that. It's just simply you've got to use it just for your own, one user for whatever you want. And this is the issue that the Acorn DDE I think was £179, and the Acorn C was £179, which was a heck of a lot, to get these sort of tools. So going back to the Acorn Electron. Acorn brought out a basic editor, which was invoked with the command BE. In fact, the command BE still works, but it won't do anything. And in fact, if you go into here, that's the module on BE. I don't know if it works anymore. So that's what I had. I paid 30 odd quid for that, and that's what I used to use to edit the programs. And I remember for the Electron, I didn't have the +1 interface. I had a Slogger ROM box at the back. That was open on the top, if you remember, you could just plug the ROMs in. Well, I knew a lad over the other side of Grantham where I lived, and I used to strap it to the back of my moped and drive. And one day I got there and the ROM had gone. It's like, oh no, it's jiggled up and down so much, it's come out of the back. And I was gutted. That I'd lost my ROM.
Did you look for it?
I didn't bother. No, I wasn't walking a couple of miles just to find the ROM. A car would probably run over by then. So programming tools. So now I use Zap. I'm going to show you a little bit later some integrated development environments, both on this a little bit, but also on dreaded PC work, just to show you what the difference is nowadays. So where did we get to? CAD. we're going to show some of the early versions of RISC-CAD just as a little bit of fun. So the earliest version I can find is this, June 92. And this was an early attempt at WIMP program. I suppose it probably is the first WIMP program I wrote. You saw the version ArmCAD got up to with its self-done windows and so on. So this didn't use many windows at all. It was basically all menu driven. So you would choose off of a menu what you wanted to do. I was using Impression at the time, so I did the little icons like Impression did, and the raised bits and bobs, which wasn't Acorn's way at the time. Acorn were very much still the white squares and outlines and everything else. Print Scabby. So there's stuff there, but it's not very user friendly, shall we say. And also, one of the things I could never get my head around for quite a few years was memory management. So it would grab the amount of memory it needed on startup and would never change it. So once you got to a certain drawing size, or once you get to a certain number of drawings, it was like that was it, and you couldn't go any further. So that was an early version. A slightly later version, which was the first one I think I did with Davins Computers at Wakefield, was so this one is now we've gone to Feb 93. And we've got the Snap Toolbox as a pane on the left-hand side, and I think if we go and turn Show XY on, that's it to the bottom. So again, it's virtually the same program, other than that. All the options are there as text options. So to get anything, it was quite a pain in the backside, to be honest. But it did it. Just have a quick look at this and see that not much has changed. Like I say, all of this was basically a rewriting of the original ARM stuff with the same, not so much bad habits. You learn a bit, but there's so much program. Are you actually going to go in there and start recoding all of that just so it looks nice? When you at the time,
63,000.
You know almost to the line what every line is and what it's doing. So it doesn't seem a problem at the time. So they were the early versions of RISC-CAD. We covered RISC-CAD in the last one, so I'm not going to dwell too much on it. I'll just go and show you what the current version looks like, and you might be a little bit surprised. It doesn't actually look that much different. The variable names have got a bit bigger, the procedure names have got a bit bigger. There's the odd comment in there, but it's not fantastic still. Again, simply because there's probably getting on for 250,000 lines in RISC-CAD in total. And then multi-statement lines, if you split it all off, it's probably 500,000. So it's never going to, and for the number of people buying it, it's simply not worth the effort to go in there and change stuff. It is quite easy to go in and see what it's doing, because a lot of WIMP programs, early programs that we showed, where you had to write your own windows and so on, in a way they were the easiest programs to write, because you could enter an endless loop until the user did something, either clicked a certain mouse button or pressed a certain key. You didn't have to worry about doing anything else. You got the screen to yourself. You could control where they could move the pointer to it. You could put, limit it. So it was very easy. These sorts of programs are a lot more complex in a way, but a lot easier to write, because basically what you've got is you've got a command-based system whereby you set your program up, you open your windows, and you basically wait for the window manager to tell you what to do. It'll say, redraw me that part of the screen. The user's clicked on that button in that window. The user's chose that menu icon on that menu. So all your command becomes is, when it's that icon, do that. When it's that icon, do that. When it's that icon, do that. So it's the window manager takes care of a lot of the processing of the program, the structure of the program, that under single tasking you would probably have to do yourself. But it does force you to come back to central loops and branch off into very large procedures that might have hundreds of options. If you've got as many icons as RISC-CAD has got, You need procedures for each one of those almost, and it's like, but it's simply a, if it's this, do this, if it's this, do this, if it's this, do this. So in that respect, it becomes quite easy to work out what a program's doing and to see where it goes. Okay. So, other languages then. I looked at C back in about 95, and I thought, oh, no way. I couldn't, because as we saw there, let's just go and have a look at any of these programs, it doesn't really matter. But with the help of ZAP, you can see which is the basic keyword, which is a rem statement, which is a comment, and which is user editable stuff. Piece of cake. If you go look at a C program, I looked at a C program, I thought, oh, where's the command? No, nothing's a different colour. It all looks the same, and I just could not get my head round the language itself. I just couldn't see. It wasn't obvious to me. Well, how do I print something? Where's the print statement? Where's the load statement? Where's the save statement? It just wasn't like BASIC at all. So I discarded it. I never touched it. And then back in 2005, I thought, well, I could do with knowing it for work. I will give it a go. So I did some test programs in C. I started out by rewriting some of the stuff I've got in BASIC. And I used a wonderful library, we spoke about libraries a few minutes ago, called Deslib that I found. Not my very first C window program. In reality, it was my very first C program, which for something this size wasn't a bad stab at it. But again, it comes back to what I said at the beginning. You haven't got to be too scared about the languages. Do you know what you want to do with the program? You know how to go about it, especially with something like this where you've got a basic version of it. So, all right, well, I'll trial and error. This is where, again, interpreted versus C is compiled is a big difference. With interpreter, with RISCAT, if I introduce an error in RISCAT, it doesn't become apparent until the program trips over that line. Now, you can still get that with C, but if it was just a syntax error, it annoys me with computer languages where they say syntax error. It's like, well, you know it's wrong, I know it's wrong, why did you just not do what it should have been? But no, you've put something in lowercase, or you've missed a letter off, or something, you've not put a dot or a bracket. It's like, come on, it says missing bracket. Well, you know it's missing, put it in. but what I'm saying is it'll trip over when it gets to that line.
Microsoft Visual, I think it was Visual Basic, would let you start typing things in, and then it would auto-correct for you, and then tell you it was wrong.
Good old Microsoft. Yeah.
In C, I like the one.
You appear to be
you don't put an end of line.
Oh yeah, it thinks everything else is the same.
Line. It's like, well, it's like that.
But it's where you leave the semicolon off, but it often tells you about 30 lines down because it's trying to think it's all one statement until it finds another one somewhere. So interpreted, it'll trip over when it gets to that particular line, which could be very, very rare. It could be a combination of circumstances that it fails at with syntax errors. C is a little bit better in that the compiler will tell you that at least you've been an idiot and you've spelled something wrong or something like that. It doesn't fix the problem. There might be a genuine bug in your program that what you thought it would do and what it actually does are two different things. So yes, this was C, and I eventually got my head round data types. What I really liked about it was this: I could create my own routines and I could put them in a library that I could use for other things. So it sort of got going from there. So this was my first attempt, and it probably does a lot of things that it shouldn't do. But this always sort of got me confused. Let me just try and find it. That double equals. So you go from if A equals B, do this, and now you have to put if A equals B, do this.
Some languages, I forget which they have, a triple equal.
Triple equals. It really is.
So, and like I said, the other good thing with C was this setup structure. I don't know if some people will be familiar with structures, but just for those who aren't, in BASIC, if I've got a variable, I give it a name, which is fine. With CAD, you're always dealing with an X and a Y coordinate. So I've got two variables, now I've got X and I've got Y. So a point is represented by two variables, x%, y%, or x1, y1, x2, y2, whatever, how many pairs you want. In C, what I can do is I can tell it, like here, that I've got a data type, this was called path. Within that data type, I've got an integer for x, an integer for y, and an integer for the type of whatever it is, it'd be a line or curve, I would imagine. And that's path. And then I would give that a name, so I would just say I want a path called A. And then a.x gives me the x coordinate, a.y gives me the y coordinate, but I don't need all these extra variables tagged onto it. What's even better is, what you can do is you can say, here's a block of memory, and I'm going to give you a pointer to the start of that memory, and then I'm going to tell you what's there. And you can just step down your memory like that, so you don't need all these variables. And this was a real eye-opener for me, because all of a sudden, you can see some of these are quite complicated, they've got lots of different things in, and you can nest these. You can have one structure within another, and a structure within a structure within a structure. So it's a really powerful way of dealing with lots of data and complex data without a load of massive variables and a load of code. And we'll look at that in a minute on a more complex program. So that was that. It did exactly what the basic version did. I then moved on to more complex stuff, so I rewrote Netplot, again using DeskLib and a little bit more program, mainly file handling and so on. I don't think that ever got used though, because I just continued to ship it. I couldn't test it because I'd stopped working for memory where there was a network. I couldn't test the serial output to plotter, so I thought I'm not taking a risk of shipping it. I'll just supply the basic one, but it appears to work. So that was C, and then I started to rewrite RISC-CAD, not as a deliberate copy of RISC-CAD, but I wanted to improve it. And I think I showed Vortex a little bit at the last talk. The whole point of this was the model space and paper space that we looked at earlier, but also it was meant to be an AutoCAD clone in a way. So there was a command line, you could draw things, and we had full undo and redo. We had things like text styles, and I could change this. So if I change that font to that and set, and reopen that and click undo, it should go back to Honiton. So it was getting to be quite a large program, even after sort of 6 months of going at it. You could have multiple views, multiple drawings, as you'd expect. It was going to support a lot of different file types via plugins and that sort of thing. But again, I soon came to realise that there just wasn't the market for it on Acorn stuff. It was going to be a lot of work, and I enjoyed programming. It was a very good challenge, but you've got to have some motivation. But let's have a little look at the code, because this is a good example. When I did get into grips with C, one of the things you quickly find using Acorn's system is you end up with all these little tools. The worst program I think ever invented is Make. Make is awful because it expects you to understand how to compile, how to link, where the libraries sit on your computer and everything else, and you've got to put these into, I'm picking this bit from here, this bit from over, and put them all together, and it's like, I just don't want to do it. I'm coming from an environment where it's type, run, works, it's basic. So it was always a bit of a pain in the bum was doing it this way. I then discovered this gem of a program, Sorcery, and this is an attempt at an IDE. So let's have a little look, because we can use this to show there's a project in there which is the current Vortex that I was working on. And what this does is it sort of brings all this together for you. Without the awful make file, it generates that for you and runs it. So we've got code in here, and we've got the main part of the program. And what I was talking to you about libraries is these are all the different. You soon find with C that your program becomes quite large. Like I say, it's compiled, and what compiling means is that the compiler will take all these instructions and basically spit out a machine code program. So you've got all the benefits of coding in assembler, but you're coding in a higher level language that you can see and understand. So you can allow yourself lots of comments, you can allow yourself lots of white space to make it look clear, you can allow yourself as many lines as you like, and you notice there's no line numbers on any of this. And it's simply because the compiler will do the job of shrinking it down into the most compact space it can. So it's nice because of that, you can split code off, because there's a temptation to write it all in one program, and because it's quite large, you end up with something that's too long to manage really, to easily go from A to B and see what's happening. So what I did is I split things off, like all the file procedures went in a file one, all the screen redraw went in a redraw one, and all these are quite big, you know, in their own right. But that's where we go. But we were talking about structures. So these are the structures for. These are the structures for Vortex, and we start off with quite simple stuff. So font table entry. So we've got what is it, how long is it, the angle of the text, the size, value, is it left, centre, right, bottom, middle, top. You see all these are getting coded into just one variable called Vortex font that I can then use to define all of this. And that then gets put into the header. So if we go down to the actual format of the object itself, find it. Here we go. This is the drawing. So this is the actual drawing itself now, and this consists of the description, the version, serial, all the things you expect in the drawing header. And when we get down the bottom, there's areas that are reserved for layout, layer, font table, revision table, and then you get the objects after that by just expanding the memory. And you just say, at that memory, I'm going to tell you there's a line, you tell me what the XY value is, the so on and so on. Or you could say, I'm going to tell you there's a font, tell me what the font text is, the font size, everything else. Really, really powerful once you work out how to do it. And the way that was done, if we look at redraw, we go down and have a look at some of this. I only got a few shapes in there, so there's not that much to look at. Here we are. So we've got an address of a variable that holds an address called VP target, and that's what we're saying. There's something there, and we're looking at the type. And if it's a point, we go to the draw point routine. But we're saying at that address, I'm telling you there's a point. Go and read the variables from the point. If it's a line, we're saying at that address, I'm telling you now there's a line. The same block of data. It's just that we're telling you there's something different there, depending on what we've read as the object type. So you don't have to have a load of variables. All you need is the memory pointer and say, I'm telling you what's there. So it was very good at that, and you could do all sorts with it. I really sort of now I don't think I'd consider writing anything else other than C, which goes back a little bit to basic. So that's Sorcery, which is very good because you can have libraries. There's my DeskLib library in there, but all these are built into it. You don't have to go and faff. It's sort of set up whether you're using GCC or the Acorn DDE stuff, and it's really very good. So I would recommend anybody trying to do this sort of thing, I'm going to play with that. Just finishing off on RISC-CAD. I said it, the reason that variables are kept short and the comments are kept to a minimum and the white space is kept to a minimum is because it's interpreted, and it still is interpreted. But there are tools that you can get that will reduce it. So that's on RISC-CAD, that's what I edit, but when it's run, that's what's actually run. And it's gone through a basic compressor. Now, for years I couldn't use basic compressors because they all, without exception, had one flaw, and they wouldn't allow the eval command. They wouldn't allow it. And what eval does is, if you've got a variable, you can evaluate it at runtime. So I could set some text to be A times B, and I could say in the program at runtime, tell me what the result of A times B is, and it relies on the fact that there's a variable called A and a variable called B still existing in your program. But if the compressor's been along and changed all the variable names, it doesn't go into the text string and change A times B. So that text string suddenly becomes an error when you try to evaluate it because those variables don't exist. And RISC-CAD contained a programming language for the plotter that used variable names as the values that you could look up. So I could never use basic compressors until this one came out that I use now. And what it let you do is it let you lock certain variables from being renamed, and these are basically all the plotter command variable names. But you could lock them from being renamed so that the compressor would go through, compress it all, but it would leave all these as they were within your program. And you can see it makes a pretty good job of it. It's gone down from about 650k to 267. So it's gone down by less than half. And it also, because of that, it speeds it up by almost double the speed. So it was very good to be able to find one that would finally do the decent thing with it. Interestingly enough, I also at one point wrote again in C. I'll go back to my C stuff. Oh, actually, there should be one in here. I wrote a RISC-CAD file viewer, a bit like the Artworks viewer, so if people wanted to send drawings out that somebody didn't have RISC-CAD. And I wrote that in C, and it was interesting to compare it with how fast RISC-CAD could redraw the screen, as opposed to how fast that could redraw the screen. And RISC-CAD could redraw faster than the C could, mainly because most of RISC-CAD's screen redrawing is done in machine code. Again, it's pretty poor machine code. Again, it comes from years ago. We'll have a look. Just that embarrassment over there. But again, just same old, same old. It's just there is some comments on there, but it's still when you get down here, it's pretty sparse. I've got one for Malcolm, see if he can work out. I looked at this and I thought, oh my god, I don't believe I did that. I can find it. Maybe that.
Well, your early programs look like my Chrome ones.
Only another 25 years to go.
This was the oscilloscope one, and it used some machine code to get the screen redrawing quite quick. Screen redraw looks fast now, but like I said, the machines have moved on, and this thing runs at God knows how many minutes. So I was looking at this and I thought, I don't believe I've done that. Let's see if Malcolm can spot what's wrong with it.
I doubt it.
God, you will. You'll see it straight away, I hope.
Given how many years it is since I went to machine code, I think it's...
Oh, come on. All right. Cool. It must have been a different program. I'd actually put a command in, use the multiply command that the assembler has here to multiply by 4. What have I done wrong?
There's probably an easy way.
There's a hell of an easy way. Yeah. Multiply by 4, you shift left 2 places, it takes 1 instruction. As soon as you use multiply, it takes about 64 instructions. And it's like, what's it? Because even that would have known. So, there you go. So that was that. So that's sort of up to date. Vortex was the last thing I wrote on the Acorn, and I've not really done much since. What I'm just going to show you now, something's decided it's still running, not going to work.
Oh, no missing battery.
Yeah, just a minute. We have the technology. So I'll show you what I have to quit. This for some reason it won't exit on its own virtual icon. So I was going to show you going back right back to the beginning of early programming, and say people ask how do you program, and it's you've got to understand if, then, or, and this is something I did, and it was quite interesting, and we'll look at some Windows stuff as well. But This is actually Excel, as you probably recognise, and this is something I've done for a company who wants to measure light. But it just shows nowadays what you can do almost with off-the-shelf office programs. I dread to think how you would do this on something like Schema or Results. I don't think you could. So, typical spreadsheet type stuff. You can choose products, drop-down menus, that sort of thing. But we can put command buttons on to open and close various parts of it. We can colour various things depending on what we put in. Again, that's all fairly standard stuff. But if we look down here then, we can start graphing things and we can start inserting data onto some of these graphs. So if I go down here and put not most of the time this will be locked, so they couldn't go out of these boxes. But you can see, hopefully somewhere if I put we're up there, we've got those somewhere. So this is a light chart for all the viewable colours in the universe, or rather the ones that your eyes can see. And what you enter is what's called the XY value, and it plots it on the graph for you, and then it magnifies the relevant bit and puts it in there. So there's some quite powerful customization that you can do to some of these. This is where you actually enter the data for all this. If we go into here, it's for flashing light, so we can tell it how many flashes there are and what the time is, and you see it's giving us a timing graph then for what the waveform will look like, and this would link to external test equipment that would measure things and give you results. So you know that is typical of what we can do. But when you go back to look at what is underscoring all of this, we're still back to if and, you know, something like that. So it's very much I do a lot of this sort of thing for my wife, but she wants spreadsheets for all sorts of calculations. And she says, "How do you do it?" And it's like it's easy once you know, if and there, something like that. It's just I know the commands. I just need to know what your problem is and what you want the answer to be. That's really what it boils down to. So that was that. So I started learning Windows programming because spreadsheets are okay, but quite easy for people to copy and to poke around and change. You don't always want that. So I started to look at programming Windows. And what I'll show you now is again, this is free, this IDE. So this is what you're up against on the Acorn side, and this isn't the only one of these. There's several of this sort of IDE. And like Sorcery, it pulls it all together, but it includes everything. It includes the compiler, it includes the linker. You don't have to go out and find all these. It includes all the editing. As you can see, it's nicely saying what project you want to load. Well, that's the last one I did. And this is a simple Windows program. Windows actually isn't that much different to Acorn. It's any of these Windows environments, it's still a user clicked on this, user did this, user did this. Yes, it's a bit more intricate to get stuff on the screen, as I found out. On Acorn, if you want an icon on the screen, you create the icon, you assume the sprite has been loaded into the WIMP sprite port, and it pops up. And it took me ages to work out that that's not how Windows works. Windows has the resources, all the data for everything you do in its resource file. So all the button names, all the language text, all the messages, it's all in one file. And when you compile your code, it all gets sucked into one executable. There's no separate sprite file, there's no separate messages file, there's no separate template file. It all gets sucked into one. It's great because it means things can't go missing. You don't get somebody phoning up saying, my sprite file's gone or something like that. It's all, but that's why when you look at a Windows executable, you look at Word's executable, 8 megabytes, what they're doing in there. Yeah. It's all the sprites, it's all the windows, they're all sucked in there together.
It also means you can't use or edit the messages and create a different language.
No, you can. You can.
Without having to suck them all out again. And then
you can't. Well, no, you can do that. If the programmer decides that's what he's going. No. If the programmer decides he wants to let people edit the language, you can put the text messages outside the program.
If the programmer chooses to
Yes,
that.
yeah.
If the programmer doesn't choose to do that, the end user can't decide.
No,
Well, I
absolutely.
speak Polish, I want these messages displayed in Polish. Because the messages
You're
are...
talking about Microsoft, you have to pay for the Polish version.
It annoys me when you go on so many software download sites, you've got a huge menu. Which human language version do you require? Products to that, just give me the software and I'll write the messages file in a different language.
Yeah.
Oh no. You've got to pay to have a completely different version that
Yeah.
we paid someone to sit and translate all the messages.
And going back to the spreadsheet I showed you, I sold it to an English company, but I know it's going to be sold to a Spanish company. So I've allowed them to choose up to 8 languages, and it will go and replace all the text in the spreadsheet with, but that's going to be user editable. Everything white is user editable. So yes, I understand your pain, but that's just the way.
From around about 1988 in Riscos applications, you could. It was the de rigueur to stick all
Yes.
human language messages
In a separate file. Yeah.
And then at startup, the program would just decide which ones are used.
Yeah, it was dangerous. I mean, I did that with RiskCAD eventually, and I had to then go through and make sure that what if somebody puts a long button name in, can the button handle it? You know, I had to put extra software in there to check and alter the indirected button size so it would look at the message before it created the icon for the buttons and so on to make sure the text would fit, otherwise you get all sorts of nasties happening. So this is a Windows program, and again it's pretty much the same if you look. It's create your variables at the front, and then you've got an overriding Windows routine at the bottom that if it's this button do this, if it's this button do that. I can compile it. It's up to date, so let's put a space in there just to force it. F3 is not saying anything. That's gone. Right, so let's build it again. So it's compiling it for me, very quick, 1 second, no error, no warning, nothing wrong hopefully. So we'll run it. And this is what it did. I was just playing around. Can I get a window open? Can I get a menu? Can I choose things and realise that's what I've chosen? Can I click on stuff? Can I type something in a thing? Can I click OK? That's deliberate. Actually, it's looking that up from the things. That's not a bug. That was the cancel button and it replicates. So it was a test to see, do I understand how this works? Once you get to this sort of stage, then you think, well, I'm not going to do any more unless I've got an actual program to write. And that's sort of when the fun started. So So I wanted a simple plan. You saw on the colour chart where I could enter 2 coordinates, which are basically what's called an XY colour value. And it would say whether it passed or failed for a certain colour of product that we made. It was amber beacons, red beacons, or blue beacons. So I thought, well, how hard can it be to get that going? So this was my program. Let's just run it. So it took me about 2 or 3 days to get that icon there. Because what you do with Windows is you create an icon, but the picture isn't part of the icon. You have to load the bitmap and link it to the icon. So you get two, in Riscos, you create a window, you get a window handle. Fine, it's the same in Windows. You create an icon, you get an icon handle. Great. It's the same in Windows. But the bitmap has it as a setup. Everything has a handle. Whether you import text out of your resource file, that gets a text handle. Everything gets a handle. Then you have to tell an icon that that's the bitmap handle that goes with it. Oh my goodness. So it was frustrating. I say it's just a question of principles. Once you understand, I'm sure there's a reason. There's a reason they've done it. I can't remember which way around these go now, but I probably got these wrong. But hopefully, if I get this right, doesn't look much, but to me, this is like climbing Mount Everest. I'm hoping. Hey, it turns over. So, and it would turn blue already. So, you know, that was just an idea of me getting started with PC programming. Lastly now, just for the last few minutes, I'll show you something else. So, what's the program I'm most proud of? RiskCAD obviously is pretty good, but RiskCAD is one of these where it's quite easy to write because you've got megabytes of memory to go at. You've got putting things on the screen is relatively easy. As I said, the window manager does a lot of the work for you. There's tools to lay out your windows. It's just more of the same. A program is like RiskCAD. You end up with a kernel of a program, and it's just it just grows and grows and grows, and so on. I'll show you one of the ones I'm most proud of. Now I need to find. I only put this on yesterday. So this is another IDE, Integrated Development Environment, and this is for embedded microprocessors. And everybody knows that the ARM chip has become the embedded micro of choice for things like iPads, phones, everything else. But there's a lower level set of embedded processors that are cheap for industrial control applications. And this sort of processor would typically cost you 50, 60p, something like that. And it's Microchip do them, ST Electronics do a lot of them. Microchip are probably the most popular. They do a whole range from 8-bit, little 8-bit chips that have literally got 8 pins, 6 of which is I/O. So it's a great little thing. If instead of putting a load of old digital chips in to do AND gates, OR gates, NOT gates nowadays, you just put a micro in because they're a heck of a lot cheaper, and write some simple code. But this was always a challenge because this was the first program I wrote for this type of device. I'd never used them before, and the guys were struggling to come up with something. I said, "Give it me, I'll sort it out." My head about this big, and I sat down and I thought, "Oh, geez, what have I done here?" Because I thought, I'll do it. I'll put a structure in for this. I'll store the data in a structure, and that was then I realised that the thing has got 64 bytes of RAM. 64 bytes. Only structure was 2 words, and that's your 64 bytes gone. 2 words of 4 bytes each. That's 64. I thought, oh my God, what am I going to do here? And I've got all sorts of data I wanted to store as well. And the data, it's like, I'm going to go in there. I soon worked out that if you put the data in as let's go to header file. These are all the constants for the program. But if you put the data in as what's called a constant structure, constant means you tell the compiler that data will never change. So fortunately, the compiler knows that and puts it in ROM. You still only got 1K of ROM, and that's for your program and your data. And it was quite a challenge because we got a flashing beacon like you see on the top of police cars. And we'd had it made for us by our parent company in America, and all it did was flash, which was okay, but people expect more than flashing. For a start, they want different patterns. They want double flash, triple flash, quad flash. And also, if they put 2 on, they want these 2 to either flash in time or flash alternately. And our trusted Italian rep also wanted some weird and wonderful stuff for the Italian market, which I've never understood. So I had to do the software for it and get it in to 64 bytes of RAM and 1 kilobyte of ROM. Now, these processors are 1 instruction per byte, or 1 bit of data per byte. So I've got a combination of 1,000 instructions or 1,000 bytes of data, or a mixture of both. And you can't do anything else. The other thing with these is what was interesting. I picked up a project from a company we bought, and it was high power LEDs, as you can imagine. Some of these products really high power LEDs, which get hot very quickly. You're talking about 3-watt LEDs, 5-watt LEDs. There's a lot of heat being generated, so you see a lot of aluminium usually behind some of these things. And it's always a case of, with this sort of thing, is you've got to be, the LED is the most expensive part, and it's also the most difficult to replace. In fact, it's really not, it's not like changing a bulb. If the LED blows, the thing is done for. So you've got to protect those, both in the design thermally, but also in the software. And I couldn't believe what I was seeing. They'd written a whole program for a light bar and implemented it in hardware, where when the output of the micro was off, the lights were on. It's like, why would you do that? First off, any micro that starts up, everything's off. So you got a flash straight away as soon as it started up. And also, if things fail, it's going to go off. So your LEDs are going to come on, and within a few seconds, they're going to burn themselves out. So that was the most unbelievable thing I ever saw. But even with the flashing beacon, the software where we put it back, so off is off and on is on. You've got to be very careful in the software that there's not a bug whereby the lights stay on permanently, because they won't stay on permanently very long. So there was a lot going on in terms of that, but we added functions for synchronization, so they could connect 8 of these together, they would flash in sync or separately, and different patterns. And this is, for me, this is the best software I've ever written, and I'll show you why. Because the holy grail was to make an LED beacon look like an old beacon. It was ironic, really. An old beacon is a bulb, a motor, and a spinning reflector, a bit like a lighthouse. Costs about £6 to make. You sell it for about £10. An LED beacon probably costs you £20 to make, but they sell for £70–80 because they're perceived as long life and high value. And now they want to turn it to look like an old £6 beacon. Oh well, whatever. So I'll show you. There's no point showing you the software; it won't work on this. But what I can show you is the resultant video. So let's have a look.
It's no different to fruit machines, where
No.
the electronic ones look like drums that sort of
Yes,
kind of twitch a little bit when they stop.
yes, exactly. Yeah. So this was it. Now what you've got to look at here is the pattern on the wall, because it's not just turning the LEDs on or off. It's rising the pattern, it's rising the intensity up, and then letting it down like a bulb. Because when an incandescent bulb comes on, it can't switch on and off straight away. The intensity rises and falls a bit like a sine curve. LEDs don't do that. LEDs switch on and off so fast, it's just a flash if you're not careful. So it was to make it look like a rotating beacon. So that's what it looks like. And I have another video showing you how it's doing it from inside. This is two of them synchronized together. But we'll go and have a look at the inside. So all you've got in here is 4 LEDs doing all of that. One per face. And as one output rises, the next one comes up behind it, and the next one comes up behind it. So it looks like the light is moving round and round. And that to me, because I had to get it in a 50p micro that only has 64 bytes of RAM and a kilobyte of space, and I got static flash in it. I got an airport flash, which on airports you're not allowed flashing lights, because they look like the strobe lights that aircraft will use to land on. So you'd be driving somewhere on the runway and an aircraft would be trying to land on the top of your van. So airport lights can only come on and go off quite slowly. It's called static flash. So it would do that. It would synchronise. It had 16 patterns in it, all in that 1K. And it was so much. I got quite upset about this because the Americans saw this and said, "Oh, can we have a look at your code?" And I was really pissed off because the Americans, being Americans, if it's not invented in America, they're not interested. They don't want to know. And they made some, I won't swear, but they made some rubbish excuse to get hold of the program for this, because they said, "We just want to see how hard it is to make something rotate." I thought, yeah, you're going to pinch that and copy it. And I got quite upset with the MD, because I said, and it is, anybody who does programming like this is, giving somebody your code for this, and I couldn't stop them because they employed me, but giving somebody your code is like handing over your baby. You know, especially something like that. It's like, you swear, I won't get any recognition for that, I won't get any credit, I won't get any more pay. And
Somebody in America will.
Yes, exactly.
But
Yeah.
the space in the ROM, you need to encode your name.
Yes.
Last line of the programme.
There's a bit that stops it all working in a certain year unless you put your code in.
Microsoft encoded the word Microsoft into the floating point table of their first version of Basic.
Do any of these have any facility whereby these are dimmed at night? Because one of my pet hates is you're approaching an accident scene at night. There's all these blue flashing lights, and they're the same brightness they are on
the day.
hottest, brightest summer day.
So there are.
You can't see
Then crash into the police car.
There are the regulation for those. There are two brightnesses. But most they're called night and day. But most of what's on the road is the night setting. This was a light bar we did. Similar sort of thing.
Police ones are just far too bright at night.
This was one, an amber one, and we got actually asked to turn this down because it was too bright. I mean, this is filmed in daylight, and you see how it's affecting the camera. And what was good about this is, no matter what it's trying to show here, is no matter where you walk around the vehicle, you don't lose any light. And these are LED modules pointing straight out, but it manages to spread the light fairly evenly. You can see a bit more in detail there. So each one of those has got 6 3-way LEDs.
My hand's just on the
Yeah.
The day setting is just incredibly bright, but most of what's on the road will be set to the night setting already, because it costs more to do it. And there's no mandatory requirement for night and day. You can just get away with
So
putting
you can
it.
approach an accident scene at night, and actually you can't see where you're supposed to drive on the scene because you're just being completely dazzled.
Yeah, no, I agree. It is bad, but there's no You know, there's no required
I'm not
change.
saying it was any better in the days when there were bulbs.
Yeah, yeah. So that's sort of gone from Acorn Electron trying to squash things into a few K, right to a Peak Micro trying to squash things into 1K. So it's sort of all that early experience sort of does come in eventually.
I'll send you an 80 bytes free in your code.
I know, but I couldn't fit anything else in.
Not getting Space Invaders.
Yeah. Yeah. Anybody got anything that they want to ask? Or yes.
Yeah, I just noticed on the icons on the icon bar for there's the nut and bolt, which I thought was the risk one.
Yeah.
There's also a little drawing board.
Yeah. Yeah.
Did it change?
It did. It's been through several. But again, based on what I used to see in the magazines, one was a program Hewlett Packard did, and it was a drawing. Might be able to find it. I don't know if I've still got it, but it was a drawing with the bottom corner curled up, and I have a lot of the old. RISC-CAD stuff for really old versions. So it will probably be around version 4. Let's have a look. Oh, no, that was an icon that as well that came and went. There's a file icon. There we are. It was a whole drawing with the top sort of roller. So there's been several icons. And again, it used to be the case where you'd have to provide a low-res set of icons and a high-res set of icons, because some people had what we call their multi-sync monitors, and some had just the old standard resolution. Nowadays, you just assume everybody's got a high-res monitor, so you don't even bother doing the low-res set anymore.
Well, there's another set now, I think.
Is there?
Yeah.
What, a super high-res set?
For, I think, transparency or something
Oh,
like
right.
that. I'm not bothered even attempting to.
See, that annoys me. You look at programs like Windows with its aero mode, and as a program, you don't have to do anything, it just does it for you. Why can't RISC-OS just transparent every other pixel or something like that, if that's what it wants to do? You know, it shouldn't really be down to the programmer to mess about with all of that. So yeah,
Because for certain graphics, it's not transparency, it's translucency. So if you want to have like nicely translucent icon or something like that.
yeah, so you can see what's underneath it. Yeah,
things
Windows
like that.
aero. So yeah, so there has been several sets of that sort of thing. That was a plotter program, because plotting used to be separate to it. Probably won't see it a bit lower. So yes, there was a.
Yeah, that's when you clicked one icon and a different one came up.
Yeah, because once you run a different program, it will rename. It will rename the one it's using, because they were all called !RISC-CAD. So the one in the WIMP pool gets overwritten every time you double click a new program. Anyone? Yeah.
You mentioned earlier that essentially, well, I'm trying to read me now. Yeah, I'm not long enough.
Should have some comments and a bit of white space.
Yeah. Essentially, if you can program, you can program.
Yeah.
Problem is, employers, especially recruitment agencies, absolutely point blank refuse to believe that.
Yes, I agree.
They say, I've got 20 years experience in programming C. Oh, sod off, we're looking for a C+ program.
Yeah.
Well, C+ is just another programming
Yeah.
language.
Yeah.
If you haven't had 5 years commercial paid experience in the language that's only been around for the last 2 years,
Yeah.
they just don't.
This is typical, and I used to recruit staff through agencies, and this is typical of agencies. I had them phone me up just recently for because they said, "Are you available for a job?" And I said, "No," but I haven't been to university. Well, I never went to university. I went to college, so I got an HNC in engineering. So I haven't got a degree. And the first thing is, they can't do this, it's illegal. I told them this, but she's, "Oh, you haven't got a degree?" Phone down, almost straight away, because it said a degree.
Yeah.
And I said to her, "Just a minute. If I had a degree, it would have been 20 years ago. What relevance is
I
that
keep getting
now?"
asked what they call now. What GCSEs have you got? And I said, I don't have GCSEs.
Yeah.
I've got O-levels.
Yeah.
That's
I
right, yeah.
can't remember what my marks were in my O-levels. That's 33 years ago.
Yeah, this is just a way. Like I said, I do talks for school kids who about to leave school about how to go to interview and what to. And I read an article which I tell them about. And it was said that the average time that your CV is looked at now is 9 seconds.
Yeah.
So if by 9 seconds, which is about the first 10 lines, if you haven't got the retention in that time, it's bin and on to the next one. That is just ridiculous because a lot of people put the qualifications at the end.
Yeah.
It's like a big mistake.
Yeah.
So it is stupid. I agree. It doesn't. What I say, I think is right though. You either know how to program or you don't. Getting a job in programming is a different issue. You're right in terms of experience. They want experience and they want it in all the current languages.
And quite often they want several years' experience of exactly the project they are currently working on, which you can't get without already being employed.
Yes. In other words, they want the person they've just fired.
That's right, yeah. Take me up the rate.
Yes. Yeah. Come back as a consultant.
We have to run courses for employers.
I sometimes wonder how someone I had an HND, how I would ever get a job nowadays.
Yeah.
Yes, I know.
Yeah.
I know. Most of it, I suppose, is word of mouth. It's experience gets you a long way, but also the people that you knew and know what you can do. That's really what it comes down to.
I don't know about you, I came into a job market where there was no such thing as long-term unemployment.
Yes. Yeah.
I guess didn't exist.
Yeah.
Short-term unemployment, yeah.
Yeah.
Not long-term.
I walked into my first job by just walking into an office and saying, "You got any vacancies?" No way you can do that now.
No, I don't think so. No. Security would be taking you out, wouldn't they?
Not long now.
Effectively, I told them to create a vacancy, Aaron. You need me. You create a job for me.
It was interesting because I must look younger than I actually am. And when I was doing the software for that rotating beacon, we got an agency guy, electronics guy, walked out. He had his family had health problems, so he had to literally up and go. It was halfway through the hardware for that, so we had to get an agency guy who, it was a nightmare. We kept him for only about 3 or 4 weeks. But I was working on the program, so I was in my office tinkering away. And it was funny because he came up to the door, and he must have been late 50s, early 60s. And he came up to my office door, leant on the door frame, which always annoyed me, and said, he says, I've done a bit of programming in my time. I haven't done any for about 10 years, but if you're struggling with that, I've got about 10 years experience. I just looked him in the eye and said, that's good. Only about 20 years less than me. So he sort of beetled off. And, but yeah, it's I hate to think we'd have still been on the project if I had given it him to do. But yeah, no, I enjoy programming. Like I said, to me, it's one big puzzle. I get frustrated where I can't find out why things don't work, like the icon and the bitmap in Windows and so on. But certainly there is a lot of good online help now. There's a lot of good.
That's the big difference, isn't it?
Yes.
You've got this enormous.
I was going to bring in. I got a programming book for Windows, which anybody who remembers the Win programming book said about that thing. Well, the Windows one is about the same, but it's nowhere near as comprehensive. I thought I'd be getting a book that told me every call in Windows.
Exactly. That's your program. You get the reference manual, which is
But it doesn't exist for Windows. The reference manual is only
a lot
online.
of programming languages now. I'm struggling putting together PHP programs because you think, well, I should be able to do this, but there's no 100% list of every single possible command that you can skim through and think, yes, that looks right.
Exactly, and that's how I used
You
to.
end up having to sort
I
of
agree.
Google around.
Yeah, and also I like a book in front of me as well. You have to
And if you've
start.
got this ability, why doesn't so and so
Yes.
not work?
Yeah. I mean, that's the perfect thing about like 6502 reference manual. You've got all
Yeah.
178 opcodes and exactly what they do.
Yeah.
Viscos Programmer's Reference Manual, you've got every single swine code listed telling you what they do. And from that, you can just build up.
Yes.
But it's difficult to get that sort of information with model systems.
Yes.
It's a lot more complicated though. I mean, it's if you were sort of saying like Risk OS, if you look at the, if you're just using SWIs, you can use the reference manuals. I mean, I'm just using Toolbox at the moment, and using the PDF, I just can't be bothered. So I mean, I just use Find and on the header files.
Yeah.
It's not really the
I
best
taught
way.
myself C just reading through the header files that came with the
But things,
license
I mean,
compiler.
things like PHP, there's so many libraries and so much more complicated than Risk OS. I mean,
Yeah.
you can do PHP code to do servers, TCP. You know, there's all libraries, and the main problem with PHP is there are 5 million libraries to do each individual
To
thing.
do
you
1
do
million
once.
things.
Well, no, to do one thing.
Yeah.
So you say, I want the library to, I don't know, parse an XML file. Right, you've got a choice of 60.
And there's a sort of like random scattergun approach to naming things. Like one thing I was looking for, I was needing to parse something left to right, and then later I needed to parse it right to left. And the left to right one was something like parse left word. So I was thinking, right, it must be parse right word. No, it was something that didn't even have the word parse in it. It was something like right string subchop or something like that.
This is it. This is the problem with libraries: is you're always trying to get into the mind of the person who did it. And like I said, I like Deslet because there's a nice strong help manual that goes with it, and you just click on the bit you want, it tells you exactly what.
The programming libraries I write, I try to write so they're orthogonal, nice and structured, and I write them, and I try and write them so they're understandable by somebody other than me coming on them fresh.
Anybody else?
The cultural difference there, don't you think?
Yeah.
That's the thing.
Okay. Thank you very much.
Rock, helping you with Acorn and Riscos computing.